Today I'm going to talk about the descriptive approach to quantifying the similarity of graphs. Imagine if you are given a large set of different images and you have to find out the ones which are more similar to each other. Or you entered a query in your browser and you want to find out the best results according to your query. To accomplish all these tasks, a very popular approach called graph at a distance is used. So the data is represented by graphs, and the nodes represents the objects, where the edges between the nodes represent the relationship between the objects. According to this approach, the minimum amount of edit operations required the minimum amount of required edit operations required to transform from one graph into the other graph is called the graph at a distance. So the edit operations could be the insertion, substitution, and deletion of both nodes and edges. And there could be a large number of edit paths from if we move from one graph to other graph. But we have to select the one which provides us the minimum edit cost. And now the approach that we are introducing is based on near set theory, which provides the theoretical framework to assess the nearness between disjoint sets of objects. And the tallness nearness measure gives us a view of the world where transitivity is not required. According to this approach, we have to find out the distance from each node of the first graph to each node of the other graph, and then in a big graph we have to find out the maximal cliques. So once we have found out the maximal cliques by using the tallness nearness measure equation, we have to put the values of the by using all the values of the maximal cliques, the total number of nodes involved in the in all the maximal cliques, and then the with the total number of nodes involved from the first maximal cliques with the proportion of nodes from the first graph to the second graph. And if we have another maximal clique, then the number of nodes involved in the second maximal clique with the proportion of number of nodes involved from the first graph to the second graph would provide us the tallness nearness measure. There are a large number of applications in this area, but currently we are focusing on images and letters. Thank you so much.